We want to discuss what we call soil horizons here. Now, again, watch those. There's two videos over in the weekly chapter module, so watch those and they'll give you, especially they'll show you how this works out in the field with scientists going out, soil scientists going out and working in the field with, give you an example of soil horizons. Now, think of soil. If you were to dig down and into the ground, you would see different layers, okay? And this is your soil profile. It's the vertical section of soil from the surface down to the deepest roots or when you hit bedrock. And we classify these, and it's done with what we call a pedant, which is a 3D soil profile. And you'll see these in the video over in the weekly module. Each layer is called a horizon, and they're very clearly visible. There are these horizontal layers in the profile, and they are indicated by letters O, A, B, and C. And they're separated by these boundaries that reflect the differences in color, texture, structure, moisture, for example. So this is from your book, so go look at that, and this is what it looks like. So this is the peak on it, again, three-dimensional. Here's your different layers, O, A, E, B, C, and then R is the rock at the very bottom. And notice when you go out into the ground, you can see the different, you can see these different layers because of the changes in color and texture. So the O is at the top. The A, E, and B, and C, they go below the O and extend all the way down to the R. So over here, here's the O, which is the layer that's made from the organic material. A, it's richer in organic content because it's been carried down by the decomposing nutrients on top. So it's usually richer in organic content, and it's what we call the topsoil. And E is below that. It's usually sand, silt, leach-resistant materials. E is where the clays, iron and aluminum accumulate. It's usually yellow or reddish because that's where the minerals are deposited. C is the weathered bedrock and parent material. Okay, so again, you can see this. You can see the different layers, their color, and their texture. And watch those videos because that will show you how this works out in the real world. Now, soil fertility is the ability of the soil to grow plants. And you can usually tell by the color what the chemical makeup of the soil is. And very typical are reds and yellows. These are iron oxides, and you see these in the southern U.S. Prairie soils in the center of the United States are black because they're very nutrient rich. And again, you can see this in the video, but there's this book called the Munsell soil color chart, and you get a hunk of the soil and you go through and you can find its color in this, and it will reference it, and you can find out, okay, it's this, and it will tell you what the chemical composition is of that soil. Very handy. Now, soil fertility is the ability of the soil to grow plants. And again, one of the important physical properties is its texture. And the texture of the soil are the amounts of particles of different sizes. Notice you can have coarse sand where the size is up to 2 millimeters. Silt is a little finer, and then clay is finer than that even. So it's coarse sand, silt, and clay. Bigger particles, medium, smaller. And the soil texture triangle, which I think is on the next slide, will show you this in various proportions. And then what we call the loam, that's where you have this balanced mixture of this, where everything's in equilibrium. So there's your soil triangle. and it's based on the relationships, the percentages of silt, sand, and clay. And that will give you some idea of the composition of soil and whether it's going to be conducive for growing agriculture, or if it is, what kind of agriculture is best for it. So again, the soil fertility, using this is one way to determine whether it's good for plant productivity. So here's some examples: granular, blocky, what we call prismatic or columnar, and then lady, if you will, where it's kind of layers. It's usually tight. That's usually clay. So soil can be brittle or hard. It has a consistency, the ability of the soil particles to be cohesive. You want to know the porosity, the spaces between soil particles, because that controls the flow of water and air. And then moisture, because plants grow best when soil is at its field capacity. Okay, and then you have chemical properties as well. The certain chemicals will attract other chemicals that are critical to plant growth. And that's why we're interested in the pH factor, the acidity or the alkalinity of the soil, because that can affect this, which affects soil fertility. And from books, so plants want a particular type of mineral because that's what makes them grow, and so that's what you want in the soil. And you can do a pH test where it will tell you, well, are the soils too alkaline or are they too acid? Acid ones are like peats. Alkalines are ones that are heavy in minerals. The pure water has its neutral pH of 7.0, so anything less is acidic, anything more is alkaline. And again, if you do the mineral labs in your lab component of this class, you usually will do some type of pH test for that. Okay, I'll stop here and then we'll get into the soil types on the next one. There's lots of them, and I'm going to go through them a little quickly, but you can see in the book there's a graphic which will show you the soil regions over the whole world.